Hello and welcome to Algebra 1, Lesson 37. In this video, we're going to learn about factoring out the GCF. Again, this is known as the greatest common factor. So basically in this lesson, we're going to learn how to write a polynomial as a product. So this process is known to us as factoring. And essentially all we're doing is we're reversing the distributive property. So let me kind of start off with a brief review of this. And at this point in Algebra 1, you should be very familiar with the distributive property. We use it all the time to simplify. So if I have something like A times the quantity B plus C, we know that we can take A and multiply it by B, and I'd have AB, and then plus A times C, AC. And essentially all we're going to be doing is reversing this. I'm going to see something that's AB plus AC, and I'm going to go to A outside of the parentheses times that quantity B plus C. And we'll see how to do that in a minute. Another example, A times the quantity B minus C. So we have A times B, this is AB, minus A times C, or AC. We can even do this with numbers involved. So we have 5 times the quantity 3 plus 2. This is 5 times 3, 5 times 3, plus 5 times 2. 5 times 2. And when you get an example with numbers, it's easy to show that it's mathematically valid, right? If I do 3 plus 2 first, that's 5. 5 times 5 is 25. If I do it this way, 5 times 3 is 15, and then 5 times 2 is 10. If I sum 15 and 10, I get 25 as well. So last one here, we have 5 times the quantity 3 minus 2. So 5 times 3, 5 times 3, minus 5 times 2, 5 times 2. And again, if you want to see that this is mathematically valid, 3 minus 2 is 1. 5 times 1 would be 5. If I look here, 5 times 3 is 15. Again, 5 times 2 is 10. 15 minus 10 is again 5. All right, so factoring is essentially the opposite of the distributive property. So we are pulling out what's common to all terms and placing it outside of parentheses. This is something you're going to do for the rest of your life. It's not something that you're just going to do for, one little section in Algebra 1 and then you can kind of forget about it. You will become very, very good at factoring. And kind of as you move forward, the factoring gets tougher and tougher. The stuff we're going to look at in this lesson is going to be very, very simple, very, very straightforward. All right, so let's take a look at our first example. And again, what we want to do here is factor out the GCF, the greatest common factor. So if we're going to factor out the greatest common factor, the first thing we need to do is find the greatest common factor. So what is that here? So the GCF is equal to what? Well, if I look at this first term here, I have 8x, okay? And if I look at the second term, I have 20. Now, there's no x involved in both terms, so it's not going to be part of the greatest common factor. So now I'm just thinking about 8, and I'm thinking about 20. So 8, I can think of as what? It's 2 times 2 times 2. And 20 is what? It's 2 times 2 times 5. So it's pretty easy to see that the greatest common factor here is 4, right? 2 times 2. All right, so once we know that, we kind of move on to our next step. And before I kind of get into that, let me one more time show you the distributive property with something we've already seen. So let's say I have, again, A times the quantity B plus C. So I take A, I multiply it by B, I get AB. I take A, I multiply it by C, I get plus AC. Now, what if I was to start out with AB plus AC, and I want to go into this format? In other words, I want what's common, or the greatest common factor, which in this case is A, to be outside of a set of parentheses. How do I get this space and this space? What do I do? Well, there's kind of two ways you can think about it. The easiest way to do it would be just to take each term here and divide by what you're putting outside of the parentheses. In other words, if I took AB and I divided by A, I get B. If I took AC and I divided by A, I would get C. And the reason that works is because, remember, division is the opposite of multiplication. So if I take AB and I divide by A, I get B. If I was to multiply A by B, I get AB right back, right? It's just the opposite operation. So the other thing that you can do, if you don't like doing it that way, you could take this, AB plus AC, and you could just think about, okay, I'm taking this A that's common to both, and I'm placing it outside of a set of parentheses. So that's going to go there. Then I could say, well, what's left after I take that A out? Well, there's just a B there, and then there's just a C there. Right? That works just as well. So now, taking this example and applying it to this, what are we going to see? Well, if I have 8x minus 20, and I know my GCF is 4, so let's write 4 out there. Well, again, I can start out by just saying, okay, each term divided by the GCF. 8x over 4 is 2x. And then minus, we'd have 20 over 4. That's going to be 5. So I've just factored my first polynomial. I took 8x minus 20, and I said this is equal to 4 times the quantity 2x minus 5. And again, if you want to check this, it's very, very easy. All you have to do is do the multiplication. Okay, so 4 times 2x is 8x. 4 times negative 5 is negative 20. So bam, right there, I know I got the right answer. Now, one thing I want to draw your attention to. A lot of students will understand how to factor, but they'll make a mistake and not get the correct GCF. So, for example, let's say I put 8x minus 20, and I only factored out a 2. So I put a 2 here. So then 8x divided by 2 is 4x. 20 divided by 2 is 10, so minus 10. If your teacher asks you to factor out the GCF, this is not the right answer. This is wrong, because I only factored out a 2. I have 2 that's common to each term inside the parentheses that can come out. So you might end up getting the wrong answer even though you factor correctly because you didn't pull everything out that you could. So pay close attention to that. Now, the other thing I want to do, I just want to show you really quickly the other method that I kind of used over here. So I could have written this as 4 times 2x minus 4 times 5. And again, this makes it easier to visualize. I'm pulling out a 4. And again, that's going outside of a set of parentheses. So that's going to go there. And then what's left? Here it would be 2x. And then minus here, it would be 5. So again, I get the same thing either way. So however you want to look at that, those are the two basic methods you can use to take that polynomial and write it in factored form. All right, let's take a look at another one. So we have 2p plus 5p squared. So again, the first question is, what is the greatest common factor? And it's pretty easy here because 2 is a prime number and 5 is a prime number. So the only thing these have in common number-wise would just be the number 1. So kind of moving on, we see that they each have the variable p. One is p to the first power, one is p squared. So you use the exponent on the variable that's smallest. In this case, that's going to be 1. So the greatest common factor is just p. All right, so to factor this guy out, again, I'm going to put p outside of a set of parentheses. So inside, what am I going to use to fill these two spaces? Again, I can do it two ways. I can divide 2p by p. 2p by p. That's going to give me 2. And then I can divide 5p squared by p. That's going to give me, this will cancel with this, 5p. So 5p. And then the other way, again, if you're more comfortable doing it this way, you could also say, okay, well, I have 2 times p. I'm going to write this in a different color. And then plus, I have 5 times p times p. So then it makes it completely obvious that I'm going to pull this out in each case, pull this out, place it outside the parentheses, and then what's left? So I'd have a 2 here, plus in here I'd have 5p. So either way you want to do it, you would get p times the quantity 2 plus 5p. And if it makes you feel more comfortable, because I know none of this is in standard form, you could flip the order of this to begin. So you could say 5p squared plus 2p is equal to, and then you'd have p times, flip the order of this, 5p plus 2. And again, you can check it with multiplication. P times 5p is 5p squared. P times 2 is 2p. So you get 5p squared plus 2p. All right, so here's another thing that's tripped students up a lot. So sometimes it is convenient to pull out a negative 1. The result is not the true GCF, but it's common practice. So your teacher might say on the instructions to pull out the greatest common factor, but it might be more convenient for you to pull out a -1. And this might not result in this section, but kind of moving forward, in the next section, when we start talking about factoring by grouping, you're going to see right away that sometimes you have to pull out the negative of the GCF to get everything to work out. So let's take a look at this real quick. So I have -20v to the 5th power minus 15. So what is the GCF here? The greatest common factor. Well, if I look at -20v to the 5th power, and I look at -15, I know there's no variable involved. So I can really write -20 as -1 times 5 times, let's just say 4. Let's shorten it a little bit. And -15 I can write as -1 times 5 times 3. So the GCF, the greatest common factor between the two, is 5. So let's start out by doing it with that. And then we're going to try -5, right? Because we have a common factor of -1 between the two. So let's start out with just 5. So this is equal to, I'm going to put my greatest common factor out in front. And I have my parentheses, space, minus space. Okay. So if I took -20v to the 5th power and I divided by 5, this would cancel with this and I'd have -4. So I'd have -4v to the 5th power. Then minus. Next I'd have 15 divided by 5, and we know that's 3. We know that's 3. So that's factoring out the greatest common factor. But again, sometimes you might not want to do that. Sometimes you might want to factor out a -5 because you might not want minus signs in here, right? So if I factored out a -5, what would I have then? Well, if I think about this, -20 divided by -5 is +4. Then I have v to the 5th power. -15, I'm going to include that sign there. -15 divided by -5 is +3. So either way you do it, if you went back and used your distributive property, you get this back. But by definition, 5 is the greatest common factor, so this would be the true answer. But again, in some cases, you're going to need to factor out the negative of the GCF, and so you'd want to do it this way. All right, let's take a look at another one. We have -2y to the 8th power x cubed plus 10y to the 10th power plus 8y to the 5th power x cubed. Okay, so what is the greatest common factor here? Well, I know that there's a y in each term, but there's not an x in each term, so x won't be involved. The variable part is pretty easy. The lowest exponent on any of the variables is a 5, so there'd be y to the 5th power. And then as far as the numbers go, each one is divisible by 2. 2 is the smallest number, and it's a prime number, so it's going to be 2y to the 5th power. So I'm going to pull that guy out. I'm going to have 2y to the 5th power, and then it's going to be times, I'm going to have 3 spaces here because I have 3 terms. So again, I could just divide each, so -2y to the 8th power x cubed divided by 2y to the 5th power. -2 over 2 is -1, so I'll just put a negative out in front. Then y to the 8th over y to the 5th is y cubed. And then x cubed is just going to come along for the ride here. All right, let me erase this. Kind of move to the next term. You'd have 10y to the 10th over 2y to the 5th. 10 over 2 is 5. Y to the 10th over y to the 5th is y to the 5th. All right, for kind of the last term here, we have 8y to the 5th power x cubed. This is over 2y to the 5th power. 8 over 2 is 4. Y to the 5th over y to the 5th is 1. So you would get 4x cubed. And so we have our answer here. In factored form, this is 2y to the 5th power times the quantity -y cubed x cubed plus 5y to the 5th power plus 4x cubed. Now, again, you might come across a situation where you want to factor out the negative of the GCF. So if I factored out a -2y to the 5th power, all the signs in here would just change, right? So if I multiply or divide by a negative, it just changes the sign. So this would be plus, this would be minus, this would be minus, right? But again, if I change this back to plus, then this becomes minus, plus, plus. So for the next one, I have u to the 6th power v squared plus 2u to the 8th power v minus u to the 10th power. So what is my GCF here? There's obviously not going to be any numbers involved. I have u to the 6th power, u to the 8th, and u to the 10th. A v is not going to be involved because it's not common to everything. So my GCF here, my GCF is u to the 6th power. So let's pull that out. And what's going to be left? Well, if I have u to the 6th power v squared over u to the 6th power, this is going to cancel and I'll just have v squared. If I have 2u to the 8th power v over u to the 6th power, this is going to cancel with this. I'll have u to the 2nd power or u squared. So this will be plus 2u to the 2nd power v. Then minus, if I have u to the 10th power, u to the 10th power over u to the 6th power, we're going to cancel this out, and this will be a 4. So this will be u to the 4th power. And so I'd have my answer. U to the 6th power times the quantity, v squared plus 2u squared v minus u to the 4th power. All right, let's take a look at another one. We have negative 5u squared v minus 25uv plus 45u cubed v cubed. So my GCF here, if you look at the number parts, it's going to be 5, right? You have 5 here. 25 is 5 times 5. 45 is 5 times 9. So it's going to be 5. And then for the variable part, you have a u in each case and you have a v in each case. The smallest exponent on each is a 1, so it'll be uv. Okay, so if we want to pull this guy out, let me write this down here. You'd have 5uv outside of parentheses. So I'm going to divide each term here by this. So negative 5u squared v over 5uv. We know that negative 5 over 5 is negative 1. U squared over u, this is going to cancel, be u to the 1st power. V over v is 1. So you'd have a negative u basically. Negative u. And then you would have minus. We have 25 uv over 5uv. So the uv in each case is going to cancel. 25 over 5 is 5. So this is minus 5 here, and then plus. Next we have this 45, again 45 u cubed v cubed over 5 uv. So then 45 over 5 is 9. U cubed over u is u squared. V cubed over v is v squared. So this is going to end up being 9 u squared v squared. Okay, so that's my answer. 5uv times the quantity, negative u minus 5 plus 9u squared v squared. Now, again, I want to come back to the fact that we can also do the negative of the GCF. Let me show you a little trick for this. One other way you can do it. So let's say I decided to factor out a negative 5uv. So let's write this as negative 1 times 5 times u times v. And then instead of minus, I'm going to put plus. I'm going to put negative 1 times 5 times u times v. And then plus, one more time, instead of 45, what can I write? I can write negative 1 times negative 1, right? Negative 1 times negative 1 is positive 1. So I'm not really doing anything illegal. Then times 5 times 9. And then I need a little bit more room. So times u times u times u. Let me move this over a little bit. And then times v times v times v. Okay. So if I look at the negative of the GCF, that's negative 5. So that's negative 5. And then for the variable part, it's uv. So I'm going to circle that in each case. Negative 5 uv. So negative 5 and then uv. So if you think about it here, what would be left? Right? If I pulled out the negative of the GCF. Well, if I pulled out a negative 5 uv, what's left in this case, I would have a u only. And then here I would have a plus 5. Then here I would have a negative 9u squared v squared. Okay? So using this little trick, I can do it the other way. And you can see that all I did was change the sign of everything. Instead of this being negative, it's positive. Instead of this being negative, it's positive. Instead of this being positive, it's negative. So you can always use little tricks like -1 times -1 is +1 to kind of write this in a longer format. I know some of you like to write it this way versus dividing each term. I've seen a lot of students have a lot of success with this and just really hate doing the division. So if this works for you, I think that's great. Use it. If it doesn't, then by all means, use the division. Either way, you get the right answer. All right, let's take a look at the final problem here. I have 16x cubed y cubed z to the fourth plus 20x to the fourth y squared z minus 2x cubed y squared minus 20x y squared z squared. All right, so what is the GCF? Well, for the number part, I know it's going to be a 2, right? Because everything's divisible by 2. 2 is the smallest number, so it's going to be a 2. For the variable part, everything has an x. The smallest exponent is a 1. Then everything has a y. The smallest exponent is a 2. But not everything has a z. This doesn't have a z here. So the GCF would be 2xy squared. Now, pull this out. And we're going to have 4 terms here. So if I divide this by 2xy squared, so 16x cubed y cubed z to the fourth over 2xy squared. And eventually you're going to be able to do this in your head, but for right now I want to just make it completely clear. 16 over 2 is 8. X cubed over x is x squared. Y cubed over y squared is y. So this is going to give me 8x squared y z to the fourth. And then we'll have plus. For the next term, I'm going to have 20x to the fourth power y squared z over, again, 2xy squared. So 20 over 2 is 10. X to the fourth over x is x cubed. Y squared over y squared is 1. So I'm going to have 10 x cubed z. And then move on to the next term. I have minus 2x cubed y squared. And this is over, again, the GCF of 2xy squared. So negative 2 over 2 is negative 1. X cubed over x is x squared. Y squared over y squared is 1. So this would be negative x squared. And then lastly, we have this term here, which is negative 20 xy squared z squared over 2xy squared. Okay, so let's divide this by this, and I'll get negative 10. And then x over x is 1. Y squared over y squared is 1. So essentially, I'll just have negative 10z squared. So minus 10z squared. So now I'm done. So let's erase this here. And let me kind of put equals. And let me move this down over here. And I'll move this up. Okay, so we've written this as 2xy squared times the quantity, 8x squared y z to the fourth, plus 10x cubed z minus x squared minus 10z squared.